Picture this. It's Friday night, 11 p.m. Your team just merged a critical pull request, a long-awaited feature that took 3 sprints to build. Everyone closes their laptops. Nobody is watching a terminal. Nobody is manually deploying anything. And yet, the code ships. Tests run. The build compiles. Staging gets the update. All while the team sleeps. How? Because of events and triggers. In GitHub Actions, an event is any activity in your repository that can wake up a workflow. When that PR was merged, GitHub fired an event. The event matched a trigger in your workflow file. And the whole pipeline started automatically. This is the core promise of CI/CD automation, and it all starts with understanding how workflows get activated in the first place. Without events and triggers, your workflow file is just a document sitting in a folder, doing nothing. With them, it becomes a living system that responds to your team's work day or night, Friday or not. In this chapter, we're going to map out every major event type, understand how to filter them precisely, and explore the edge cases that catch even experienced teams off guard. Let's start at the very beginning. So what exactly is a GitHub Actions event? At its simplest, an event is any activity that occurs in your GitHub repository. Someone pushes a commit, that's an event. Someone opens a pull request, that's an event. A scheduled timer fires at 2 a.m., that's also an event. Even an external API call can be an event. Think of it with a simple metaphor: events are alarm clocks, and workflows are morning routines. The alarm doesn't care what you do after it rings, it just wakes you up. What happens next is defined by your routine. GitHub supports over 35 distinct event types. There are code events like push and pull _ request. There are collaboration events like issue _ comment and discussion. There are lifecycle events like release and delete. And there are automation events like schedule and repository _ dispatch. The beautiful thing is that your workflow only activates for the specific events you declare. Everything else passes silently. 100 issues could be open today. If your workflow only listens for push events, it won't stir. That selectivity is what makes GitHub Actions efficient and predictable. You choose exactly what wakes your pipeline up. Every GitHub Actions workflow file starts with a name, and then immediately declares its triggers using the on key. This is the gateway GitHub reads on, first to decide whether this workflow should run at all. The on key comes in 3 flavors. The simplest form is a single event name, on push. This means the workflow fires anytime code is pushed anywhere in the repository. The second form is a list, on push pull _ request. This is an or relationship, either event alone is sufficient to trigger the workflow. The third form is the full syntax with options, and this is where the real power lives. You write on as a mapping, then list each event as a key with its own nested configuration. This lets you specify activity types, branch filters, path filters, and more for each event independently. One important rule: you cannot mix YAML shortcuts and options for the same event. If you need filters, you must use the full mapping syntax. Also worth knowing, the events listed under on always have an or relationship with each other. A workflow with on, push and on, pull _ request will run if either event fires. As your pipeline grows more complex, that or logic becomes something you rely on deeply. The push event is the workhorse of GitHub Actions. Every time someone runs git push, whether it's a single commit, a batch of commits, or the initial push of a new branch, this event fires. By default, push triggers on every branch. That's rarely what you want in production. You almost always want to add a branches filter to restrict it. Push to main triggers the deploy pipeline. Push to any feature branch triggers the unit tests. That's a clean, common setup. What makes the push event especially powerful is the data it carries. When your workflow runs in response to a push, GitHub populates a rich context object. You get the commit SHA, a unique identifier for exactly which code is being tested. You get the author's name and email. You get the commit message. Some teams use this to include flags like skip CI to prevent triggering the pipeline. And you get the list of changed files, which pairs beautifully with path filters. Inside your workflow steps, you access all of this via github.event.notation into the event payload. For example, github.event.head_commit.message gives you the commit message. This data flows through your entire workflow, making the push event one of the richest trigger sources in the system. The pull _ request event is your quality gate. It fires across the lifecycle of a pull request, and it's the primary trigger for CI pipelines that protect your main branch from broken code. By default, the pull_request event activates on 3 activity types: opened, when someone creates the PR for the first time; synchronize, which fires every time new commits are pushed to the PR's branch; and reopened, when a previously closed PR is opened again. These defaults cover 95% of CI use cases. But you can extend it. Adding closed to the types list lets you trigger cleanup workflows when a PR merges, perfect for deleting preview environments. Some teams also use label to trigger workflows when a specific label is applied, like deploy preview. One critical concept: the pull_request event triggers the workflow on the merge commit, the imaginary commit that results from merging the PR branch into the base branch. GitHub Actions actually tests the merged result, not just the PR branch alone. This means your CI is testing what the code will look like after merge, not before. That's a subtle but important distinction that makes pull_request CI much more reliable than naive branch testing. Not everything should be automated. Sometimes you want a human to press a button and consciously say, "Run this now." That's exactly what workflow_dispatch provides. When you add workflow_dispatch to your on key, a run workflow button appears in the Actions tab of your GitHub repository. Any authorized user can click it, fill in optional inputs, and manually trigger the workflow. This is indispensable for hotfix deployments, manual database migrations, or running an expensive integration test suite on demand. The real superpower is the inputs system. You can define named inputs with types: string for free text, boolean for a checkbox, choice for a drop-down menu, number for a numeric value, and environment for selecting a configured GitHub environment. Each input can have a description shown to the user, a default value, and a required flag. Inside your workflow, you access inputs via the inputs context, the expression github.event.inputs.environment or the shorthand inputs.environment. Combining workflow_dispatch with choice inputs is a pattern you'll see on every serious operations team. It gives you deployment controls directly in GitHub with a clear audit trail of who triggered what and with which parameters. Not all automation is reactive. Some of the most valuable pipelines run on a fixed schedule regardless of what the team is doing. Nightly security scans, weekly dependency audits, monthly cost reports. These all belong to the schedule event. The schedule event uses standard Unix cron syntax, 5 fields separated by spaces. Reading left to right: minute, hour, day of the month, and day of the week. Asterisks mean every. So the expression 02**1 means, at minute 0, hour 2, any day of the month, any month, on weekday 1, which is Monday. That's 2 a.m. every Monday UTC. A few things to know: scheduled workflows only run on the default branch. You can't schedule a workflow to run on a feature branch. GitHub also enforces a minimum schedule interval of 5 minutes. And in practice, high load periods on GitHub's infrastructure can cause scheduled runs to be delayed by up to a few minutes, so don't depend on exact second precision. You can define multiple cron entries under a single schedule key. Each entry gets a dash prefix and its own cron expression. This is useful when you want nightly runs plus a special Monday morning check, for example. Cron scheduling transforms your CI system from a purely reactive tool into a proactive guardian of your codebase. The release event is what separates code that's been merged from code that's ready to ship. It fires when activity occurs on a GitHub release, the structured versioning mechanism built into every repository. The most common pattern is triggering on published, meaning the release was explicitly made public, not just created as a draft. This maps perfectly to semantic versioning workflows. Your team tags a commit, creates a GitHub release with release notes, clicks publish, and the event fires. Your workflow picks it up, builds a production Docker image, publishes to your package registry, and deploys to production, all from that single human action. Why use release instead of just tagging? Because releases add a human approval step. A tag is automatic, it happens when someone pushes one. A published release requires deliberate action in the GitHub UI. That intentionality is exactly what you want before triggering a production deployment. Inside your workflow, the event payload is rich. You get github.event.release.tag_name for the version string, github.event.release.name for the release title, and github.event.release.body for the release notes. This lets you automatically include the version in your Docker image tag and embed release notes in your deployment notification, everything tied to a single authoritative signal. As your GitHub Actions setup matures, you'll want to chain workflows together where workflow B only starts after workflow A completes. That's what workflow_run is for. The canonical use case: you have a CI workflow that runs tests on every push, including pushes from fork pull requests. Fork PRs run with a sandboxed, read-only token and no access to secrets, which is correct for security. But you also need a deployment workflow that has full secrets access and can actually push to production. If you put both in one workflow, you lose the security isolation. If you separate them with workflow_run, you get the best of both worlds. Workflow A runs on pull_request, sandboxed, safe, tests the forks code. When it completes, it fires a workflow_run event. Workflow B picks it up, and because it's triggered by workflow_run rather than pull_request, it runs with full permissions in the context of your repository, not the fork. The key detail: inside Workflow B, you can check github.event.workflow_run.conclusion to see whether workflow has succeeded or failed before proceeding. This gives you a clean conditional gate deploy only if CI passed, with the security properties you actually need at each stage. GitHub Actions doesn't have to live in isolation. With repository_dispatch, any external system that can make an HTTPS request can trigger your workflows. Your Slack bot, your Jira automation, another CI system, a customer support tool, all of them can become workflow triggers. The mechanism is simple: you post to the GitHub API endpoint at repos/owner/repo/dispatches, include an authorization header with a token, and specify an event_type string. GitHub fires a repository_dispatch event with that type, and any workflow listening for that type activates. The real power is the client_payload field. This is a freeform JSON object you include in your API call, and it arrives in your workflow as github.event.client_payload. So your Slack bot can trigger a deploy and include the target environment, the version to deploy, and the user who initiated it, all accessible in your workflow steps. You declare which event types your workflow cares about using the types filter. A single workflow can respond to multiple dispatch types, or you can have separate workflows for separate types. Repository Dispatch creates a bidirectional bridge between GitHub Actions and your entire tooling ecosystem, turning GitHub into the orchestration hub for all of your engineering processes. Bare event names are rarely enough on their own. When you add branch and tag filters, you gain precise surgical control over which activity actually matters. The branches filter uses glob patterns. You can list specific names like main and develop, or use wildcards. The pattern release/star matches release/1.0, release/hotfix, release/2024 Q1, anything under that prefix. The double star pattern matches across slashes, so feature/double star matches feature/auth and feature/auth/OAuth. The branches ignore filter is the inverse, it fires on everything except the listed patterns. This is cleaner than listing every branch you want when you really just want to exclude a few. Common use: exclude Dependabots auto-generated branches so their updates don't flood your CI queue. The tags filter gives you the same control for Git tags. The pattern v-star matches version 1.0.0, v2.3.1 beta, v10, anything starting with v. This is the standard pattern for version release pipelines. One constraint worth knowing: you cannot combine branches and branches ignore for the same event. Same rule applies to tags and tags ignore. Pick one approach per event. And remember, these filters operate at the workflow level. Either the whole workflow runs, or none of it does. Per-step filtering requires if conditions inside your job definitions. In a monorepo, a single repository containing multiple services, libraries, and applications, the path filter is one of the most important performance optimizations available. Without path filters, every push to the monorepo would trigger every service's CI pipeline. A developer fixes a typo in the README and suddenly the backend API, the mobile app, the web frontend, and the infrastructure pipeline all queue up and burn through runner minutes. That's wasteful and slow. With path filters, each workflow declares exactly which files it cares about. The API service workflow only triggers when files under services/API change. The frontend workflow only triggers on apps/web or any TypeScript file. The infrastructure workflow only triggers on Terraform files. The paths filter uses the same blob syntax as branch filters. The expression src/double star matches any file anywhere under src, no matter how deep the directory tree goes. The expression star.ts matches any TypeScript file at the repository root. The paths ignore filter is the inverse, and it's especially useful for excluding documentation. Adding docs/double star and star.md means that writers can update documentation all day without triggering a single test run. Your CI stays fast and your cost stays low because pipelines only run when relevant code actually changes. Here's the logic rule that catches teams by surprise: within a single event, filters combine with and. But separate events in your on key combine with or. These are two completely different logical operations, and mixing them up leads to workflows that either never fire or fire too often. Take a push event with both branches and paths filters. For the workflow to trigger, a push must hit a matching branch and change at least one file matching the paths pattern. Both conditions must be true simultaneously. Push to main with a docs change? The workflow skips if you only declared src in paths. Push to a feature branch with a src change? The workflow skips if you only declared main in branches. Only a push to main that changes src files will trigger it. Now look at the on key level. Listing push and pull underscore request as separate events is an OR relationship. Either a push or a PR can independently trigger the workflow. They don't need to happen at the same time. This and at event level, OR at on level structure is how GitHub Actions was designed, but the documentation can be ambiguous about it. The practical consequence, when you add path filters to a push event, you're tightening that specific event, you're not accidentally filtering other events listed in the same on block. One of the most important security concepts in GitHub Actions is the fork PR model, and it trips up teams constantly. When an external contributor forks your repository and opens a pull request, the pull underscore request event fires. But GitHub deliberately sandboxes that workflow run. The GitHub underscore token has read-only permissions. No secrets from your repository are available. The workflow runs using a reference to your workflow file from the base branch, but the actual code being tested is the forks code. This is a security feature, not a bug. If GitHub gave full secrets access to arbitrary fork PRs, any contributor could open a PR, inject malicious workflow steps, and exfiltrate your AWS credentials. The sandbox prevents that. Now enter pull underscore request underscore target. This event runs with full write permissions and full secrets access. It was designed for things like leaving review comments or assigning labels to PRs from forks. The critical distinction, pull underscore request underscore target runs the workflow from your base branch, not from the fork. The forks code is not checked out by default. The deadly mistake is combining pull underscore request underscore target with actions/checkout pointing at the forks ref. You've just given a PR submitter's code full access to your secrets. The GitHub security team calls this a PWN request and it has burned real companies. If you need both secrets access and fork code, use the workflow underscore run pattern instead. As organizations scale their GitHub Actions usage, a pattern emerges. Every repository has its own CI workflow, and they all look mostly the same. Each one defines how to install node, run tests, build the artifact. When you need to update the node version or change the test command, you update dozens of files. That's the problem workflow underscore call solves. A workflow with on workflow underscore call can be invoked from another workflow just like calling a function. You define it in one place, perhaps a shared repository owned by your platform team, and every other repository's workflow calls it with the uses keyword instead of defining its own jobs. You can define typed inputs, just like workflow underscore dispatch, the calling workflow passes values and the reusable workflow uses them. You can define outputs, the reusable workflow can pass data back to its caller. And you can explicitly declare which secrets the reusable workflow needs, giving the caller full visibility into what credentials it will access. The shortcut secrets inherit tells GitHub to automatically forward all secrets from the calling workflow to the reusable workflow without listing them individually. This is convenient but less explicit. For platform-owned reusable workflows used across an organization, explicit secret declarations are better practice. They serve as documentation of exactly what credentials a shared workflow touches. Here's a real scenario. A developer pushes 5 commits in quick succession, maybe rebusing a branch or fixing a review comment in multiple quick iterations. Each push fires a push event. Each event triggers your CI workflow. Suddenly you have 5 workflow runs queued up, all testing older versions of the code when only the latest commit actually matters. The concurrency key fixes this. You define a concurrency group, a string that identifies which runs are in the same group. Any 2 runs with the same group string are considered concurrent. With cancel in progress set to true, GitHub automatically cancels all older running or queued runs in the group when a new one starts. The standard pattern uses github.workflow and github.ref to form the group name. This means each workflow and branch combination gets its own concurrency group. PRs from different branches don't interfere with each other, but multiple pushes to the same PR branch will cancel the previous run. One important warning: never use cancel in progress on deployment workflows. If a deployment is in progress and gets cancelled halfway through, your infrastructure could end up in a broken intermediate state, half the servers running the new version, half running the old. For deployments, you want to queue runs, not cancel them. Use cancel in progress, false for deployment workflows and true only for pure CI runs. Let's lock in the most commonly misunderstood behavior in GitHub Actions: event filtering. This is a question I've seen junior and senior engineers get wrong in real code reviews. You have a workflow triggered on push to main with a paths filter set to docs/$. Someone on your team pushes a commit to main that modifies src/appts, a TypeScript source file that is definitely not in the docs folder. What happens to the workflow? Take a moment before looking at the answers. The correct answer is B, the workflow does not run. Path filters use and logic within the event. The branch matches its main. But the changed files don't include anything under docs/double-star. When GitHub evaluates a paths filter, it looks at every file changed in the push and checks if at least one matches the pattern. In this case, none do. The workflow is silently skipped, no error is raised, no notification is sent. It simply doesn't appear in the Actions tab. This behavior is intentional and powerful. It's what makes monorepo CI efficient. But it means you must design your path filters carefully. If your filter is too narrow, legitimate code changes can silently stop triggering your CI, and you won't know until something breaks in production. Always test your filters with an explicit push that you know should trigger, and verify the run appears.